Hi there, welcome to another math class. Today in our lesson we'll be looking at equivalent ratios. Equivalent ratios. By equivalent ratios, we mean ratios that have equal value. These ratios are represented by different numbers or different antecedent and consequent, but their values are the same. They have the same value. Remember in our previous lesson on ratios, we looked at what antecedent is and what consequent is. Those two refer to the antecedent, so the first number in a ratio, and the consequent is the second number that appears after the colon in a ratio. So when you have ratios that are represented using different numbers, but they have the same value, you call them equivalent ratios. Now, how do you get equivalent ratios? They are obtained by you multiplying or dividing. It depends. You can use multiplication to get equivalent ratios. You can also use division to get equivalent ratios. But what matters is, if you are multiplying, you are using the same number to multiply both parts of the ratio. And if you are dividing, you are using the same number to divide both parts of the ratio. So whatever result you get when you multiply both parts by the same number will be equivalent to what you started off with. And if you are dividing, when you divide both parts of the ratio with the same number, whatever answer you're going to come up with is definitely an equivalent ratio to the number you started with. Okay, so we're going to look at how we can generate equivalent ratios. So here's an example. You have the ratio 4:7. Okay, now how do we get equivalent of this ratio? We multiply by 2. We multiply both sides by 2. So we're multiplying 4 by 2 and we're multiplying 7 by 2. So here 4 times 2, 2, 7 times 2. So 4 times 2 gives us 8 and 7 times 2 gives us 14. Then we can also multiply this same ratio by 3. Okay, so when you multiply by 3, you multiply on both sides by 3, just like we did here. So you have 4 times 3, 2, 7 times 3. 4 times 3 gives us 12, and 7 times 3 gives us 21. So what do we have? It means that these ratios, 4:7, 8:14, and 12:21, are all equivalent ratios because they all have the same value. We're going to find out how are we so sure they have the same value. We're going to do the division part of it and see how we can use both multiplication and division to get equivalent ratios. Now here we're going to use division to see that to obtain equivalent ratios of any set of ratio, you can either multiply by the same number, multiply both sides by the same number, or divide. Now we took an example where we had the ratio 4:7, okay, and we obtained 2 more equivalent ratios. So now we are doing the reverse of it by using division. We're using exactly the numbers we got from the first set of example we took where we multiplied, but now we're going to do division. So the third equivalent ratio we got was 12:21 in the one we did multiplication. So now we're doing a reverse of it. So we had the ratio 12:21. We are going to divide both sides by 3. We divide both sides by 3 and see what we get, because looking at 12 and 21, we know that 3 is a common factor. It can divide 12 and it can also divide 21 without a remainder. So let's divide by 3. So 12 divided by 3, that's what we have here, we have 4. And 21 divided by 3, we have 7. You see that this takes us back to the first numbered ratio that we had, and then we multiplied it to obtain 2 more equivalent ratios. Now we are doing division, we are getting back our number. So the second number, remember, that we got when we did multiplication was ratio 8:14. using 4 to 7. This was the original ratio we started with in multiplication. We got 8 to 14 and we got 12 to 21. Now we are reversing it, okay? So in 8 to 14, if you look at 8 and look at 14, we know that 2 is a common factor. 2 can divide 8 without remainder, and 2 can divide 14 without remainder. So we use 2 to divide these two sides. So 8 divided by 2, it gives us 4. And 14 divided by 2, it gives us 7. Again, you see we are coming back to ratio 4 to 7. So if you compare the first results we got when we used multiplication to obtain equivalent ratios, you will see that we are having exactly the same numbers, the same ratios. So that means that ratio 12 to 21 is the same thing as ratio 8 to 14, and it's the same thing as ratio 4 to 7. So these ratios are called equivalent ratios because they have equal values. So here's an example on the board. I'm carefully using this ratio still because I want us to see how it works, okay? This is the ratio we worked with. We used for multiplication to get equivalent ratios. We also used the equivalence of it to get the other parts using division method. I am still using the same, okay, for us to look at a case scenario and see how it plays out. The ratio of boys to girls in a class is 4 to 7. If there are 33 students in this class, find the actual numbers of boys and girls. We're going to see something very interesting. So to solve this, the first step here is we add the ratios, and by that I mean the antecedent and the consequent. We add them together, and 4 plus 7, that gives us 11, right? That's the first step. The next step is to divide the number of students that we are given in the class by the sum of the ratios. So the number of students we are given is 33. We have 33 students, so we divide the 33 by 11, which is the sum of the antecedent and consequent. So 33 divided by 11, that gives us what? 3. That's the second step. Now the third step is to multiply both sides by that 3. And what do I mean by both sides? You have the ratio for the girls, the boys, and then for the girls, the antecedent and the consequent. You now multiply each of them to get the number of girls and the number of boys. So since they said that the ratio of boys is 4 and that of girls is 7, that means when you multiply 4 by 3, whatever you get is the number of boys. And when you multiply 7 by 3, whatever you get is the number of girls. So 4 times 12 gives 12. That means we have 12 boys. And 7 times 3 is 21, which means we have 21 girls. Now, I don't know if you are noticing something. Remember, this ratio is exactly the one we used before. It's the one we used when we were trying to build equivalent ratios. And we worked out something, and we had ratio 4 to 7 as equivalent to this ratio 12 to 21. So we see it playing out here again. So our ratio 4 to 7, in solving this particular problem now with it, we are getting 12 boys and 21 girls. So you see what we mean when we talk of equivalent ratios. They have equal values. So I hope we have learned something. If you are really not so sure about how we did this calculation, how we came up with all of this, please refer to our previous video on ratios. That one is just ratio. This one is equivalent ratio. So the steps involved in solving problems like this, we dealt with it there. So maybe if you refer to that video, you gain better understanding. So thanks for being here, and we hope to see you again next week. Until then, stay safe and stay blessed.